Okay, so this is going to be our lesson on radian and degree measure, and this is the start of our trigonometric function unit. Most of you feel when you see, let me change this to a pen, when you see the word anything with trigonometric or trigonometry, most of you right away come up with the saying SOHCAHTOA, right? That's something that's definitely not new. You saw it in geometry, definitely saw it in some algebra, and you should have seen this last year. And this whole lesson actually should be review, but it was right before we went out on quarantine. So regardless, we're going to review it. All right, so SOHCAHTOA, many of you can tell me S stands for sine, C stands for cosine, T stands for tangent, and we know, just like Pythagorean theorem, trigonometry only works in right triangles. But the big thing that we forget is that it's always sine, cosine, tan of an angle. It's not just sine by itself. There always has to be some angle involved, and that angle is often referred to as theta. That's the symbol for theta. I'm trying to make it a little bit bigger so that you see it, but I think you understand. It's that little circle with that dash in between. Okay, so once you've decided and picked and identified your angle, you can then go ahead and set up any sort of trig ratio. So I'm making that be theta. And based off of that, what does O and H stand for? What does A and H stand for? O and A. Opposite, hypotenuse, adjacent, hypotenuse, opposite, adjacent. So the hypotenuse is always found across from the right angle. But you need a stated angle to decide what's opposite. Opposite's always across from the given angle that we're speaking of. So in this case, opposite's on the vertical side of the right triangle, and then this adjacent is on the horizontal in this problem. If theta changed to this top corner, well then O and A would switch. Hypotenuse would always be across from the 90 degrees. But regardless, the big thing that you need to know is you need to identify theta, okay? Theta is what you base your trig ratios off of. So that just is an angle. That's the symbol. We usually use X when we're looking for a variable. Well, we can use theta as an unknown angle, kind of like X, but instead of writing X, we use theta, and then we know definitely we're talking about an angle. So today we're going to talk about angles in degree and radian measure. Degree, we're usually super comfortable with. And radian was a short video that I posted that I'm hoping that you watched before you did this video. So first we'll just deal with angles in general. Okay, if you have an angle, here at the corner, that's called your vertex, and it's really important for you to know your vocabulary. And then there's something called the initial side, and the initial side is where the angle starts. So when I say an angle drawn in standard position, when we have an XY coordinate, it's going to be on the x-axis on the positive side. Drawn in standard position, this will always be my initial side. And then the angle, depending on how big, how small, will go, and the arrow shows me, it illustrates that it is touching the terminal side. So this piece right here, this side right here, obviously my drawing's not the best, that's your terminal side. And in this case, the arrow stopped right here, so this side happens to be my terminal side. So just to recall, this is my first quadrant, this is my second quadrant, this is my third, and this is my fourth. And you should know that in degrees, your starting position is 0 degrees. When I get to 90, a right angle, that's right here, this is 180 degrees. If I brought this angle, let me just make this a different color so you understand. If I made this angle extend to this other side of the x-axis, well, I just created a half circle, that's 180 degrees. Correct? And then if I did another 90, well then that's 270. And a full rotation's 360. Okay, so that is in degrees. We've been working with degrees for a long time. You're very comfortable with it. And before I move on to radian measure, which is what you just saw that short video on, I'm just going to take the opportunity to talk about something referred to as coterminal angles. Coterminal angles is kind of what it sounds like, co with and terminal ending. They're angles that share the same terminal side. So we can just write here, coterminal angles are angles that share the same terminal, that's a T, terminal side. All right, so for example, if I give you the angle negative 140, that's going to give me the opportunity to talk to you about what negative means on an angle. Most positive rotations of any angles go in a counterclockwise manner. So here, a positive rotation would go from this way and continue on counterclockwise. In this case, we have a negative, so we have to go clockwise. So I'm going to take that out and say, okay, well, this is 0 degrees. If I get to here, that's negative 90. This is negative 180, negative 270, and a full circle is negative 360. So where would negative 140 land? It would land, I'd start terminals in standard position, you're starting at 0, and it's going to land between negative 90 and negative 180. So if I go, okay, what is another angle that has the same ending right here? Well, think about it. If I want to be in the same spot, how much of a rotation from here should I go? I can go a full circle, that's negative, or a full circle, that's positive. So regardless, a full circle or full rotation is 360 degrees. So to find coterminal angles, to find them, let's write here, you're going to take the given angle, take your given angle, whatever it is, in this case it's negative 140, and add or subtract 360 degrees from it. That's how you do it in degrees. Right now I'm giving you a problem in degrees. We'll come back when we talk about radians, how to do it in regards to radians. So right here I'm going to add 360 degrees. This is going to tell me that when I go ahead and do the math on this, it's 220 degrees, which that sounds right. So 220 degrees in a positive direction, you know, this is 0, this is then 90, this in a positive rotation, 270. So that's right. 220 has to land in this third quadrant again, and it would go from here and land right there, landing on the same terminal side, making these two angles coterminal. So that was one way to look at it. I could have said, well, what if I want another, I don't want a positive coterminal angle. I could go the other direction. But if I wanted another positive, I could just add another 360 to it. And when you add another 360, you would get 580, and that would be your next coterminal angle. You could just continuously keep on adding 360. But a lot of times in the directions, they will ask you, state one coterminal angle that's positive and negative. So here's my positive coterminal, and my negative would just take negative 140. The biggest piece here is you got to start with the given angle. So you're going to take negative 140 and you're going to subtract 360. And when I do that, we're going to get negative 500. So negative 500 and positive 220 are two coterminal angles to negative 140. Okay, we can also do this with radian measure, which is what I'm going to speak of right now. And I'm going to also show you how to label this quadrant with these angles that we have, 0 degrees, 360 degrees, 90, 180. We're going to get comfortable and label them with radians. Okay, so from that video that you should have watched, okay, and may have remembered from last year, the definition of a radian is that 1 radian. Now remember, a radian, so let me backtrack a little bit. When I see the word radian, I know they're talking about an angle. It's a type of way to measure an angle. So for example, if I'm measuring myself in feet, if I say I'm 5'4", well, I can envision that and I can say, yep, that's probably my height. If someone turned around and said I'm 6 foot, well, if you know me, I'm definitely not 6 foot. So I know they'd be lying. But if they gave me my measurement in the metric system, as they use in Europe, I might not know so confidently because I just am not familiar with that measurement system. So this is just another way, when you see radian, it's another way to measure an angle. So an angle is measured in degrees or radians. I will say that as we do higher math, we will do mostly in radians. So we want to get comfortable with the idea and not try to continually go back to degrees or reference degrees. We want to get comfortable working with radians. So as you saw in the video, 1 radian, okay, 1 radian. So I'm going to say 1, and I'm going to say in this case is a radian. This has to equal, deals with the ratio of the radius to the arc length. And they're saying that they have to be the same. The definition of 1 radian is when the radius and the arc length are the same. So if they're the same, if I put this over each other, if I go ahead and say, okay, S arc length over radius, if they're the same, this value will always equal 1. So that's when your radian will equal 1 radian. Your angle will equal 1 radian, is when your arc length divided by the radius. If these guys are the same, you're going to have 1 radian. You don't always have 1 radian, okay? But you can, that's how the ratio is found. Now, this is really important. You can use this in, you see it in ACT, SAT. Anytime I see the word arc length, I always reference this formula. Theta is equal to S over R. Now, that one is not as easy to remember. If I cross multiplied this, okay, this is over 1, you would get S times 1, right? The denominator here is 1, is equal to theta times R. So I like this formula to remember. You can do either one. I like this one because it almost spells the word soar. So I always say, okay, arc length soar. And S stands for your arc length. Theta is your angle, but this is the big kicker. You cannot use this formula unless the angle is in radian measure. Angle in radian measure. I can't put 60 degrees into that formula. I would have to convert it. And R stands for radius. Okay, so you'll see that like on probably like a 52 on a ACT problem, ACT math section, or a number 13 on an SAT piece, because it's always towards the end. It's one of those, if you know it, great, and if you don't, then you're not going to probably guess your way through it. So they're asking you, if you say anything with arc length, SOAR is something that you would like to explore. Okay, so also from the video, you should have gotten that the degree radian conversion is that there's 180 degrees is equal to pi radians. It's equal to pi radians, and such that 360 degrees is equal to 2 pi radians. So if I wanted to go ahead and draw my X and Y axis, instead of saying 0 degrees, 90 degrees, 180 degrees, 270, 360, as I did before, I want to write it in radians. So we know that for 180, I can write pi. And for 360, this is still going to be 0 or 2 pi with the full rotation. Now think about here, to get to 90, it's halfway to pi. So I can write that as pi over 2. And then this, to get to 270, it's 1 pi and a half. So I can write that as 1.5 is 3/2, right? So 3/2 pi. So 3 pi over 2. All right, I'm going to pull